Hey folks, welcome to my channel. Today we will take a look at the 238 product of an array itself. So what does this problems means? We'll be given an integer of arrays and then return an array of answer such that the answer I is equal to the product of all the elements of the numbers except itself. And of course, there are some limitation, like the algorithm must be run in O(n) time. So probably it means that we can only traverse this array for only once. We cannot like have a double for loop or something else that will make the situation more complicated. And okay, so let me take an example to talk more about it. So this will be a list of array, right? What does it mean? Now the total array, the product will be 1 times 2 times 3 times 4. It means 4 times 6. The total product will be like 4 times 6 will be 24. And then so we will return a result like for this is our answers. Because we accept 1, so the result will be 24 divided by 1 will be 24, and 24 divided by itself 2 will be 12. And 24 divided by 3 is 8, and 24 divided by 4 will be 6. So this will be the results. And what I did is like I will traverse the whole array and get the total product is 24, and then traverse the array again to only divide it 24 divided by 1 and 24 divided 2 to get each of the results. Can we do this like this? Alright, yeah, there's another limitation. It's like we cannot use the division operation. And so the other brute force that what I'm thinking is like, when I'm in this position, I have another pointer. For example, this is the regular pointer. When I'm at this position to get results, I will initialize another pointer here. It will traverse the whole array. Like if it is at the same position as the right pointer, it will just skip. But when it is on another position, I will start to like accumulate it. Like when I move to here, I already get 2, and I get here, and 2 times 3 6, and then 4 times 6 is 24. So now I got 24 here, and when I move the red pointers here, my blue pointer will be starting from the beginning again. I will start to get 1, but when I move to next is equals to the red pointer, I will just skip it, and then move to 3. So 1 times 3 equals to 3, and then move to another. It is 4 times 3. Now it get 12. So probably this the brute force, but as we talked about before, we have to write an algorithm that run in O(n). If I have the 2 pointer, it means the time complexity will be O(n) squared. It is not allowed. And how we solve this problem? And now here we have to introduce another concept we have to know. Is called prefix sum. What is talk about? Let me show you. So here the answer will move up forward. You can copy this. Here we will start to get the answer one, or just call it prefix. Probably not prefix sum. We can also call it prefix product or something else. But of course, its original comes from prefix sum. The idea. We can also prefix product, right? What does that mean? So now we still have this pointer. When I move to 1, I will get it as 1. When I move to 2, I will start to accumulate. 1 times 2 equals to 2. And then when I move to 3, it will be 2 times 3. So yeah, let me write down. So for this one, it's only 1. It's 2 sticky. So this 1 and this will be 1 times 2. Probably we can say 1, and this one is we can accumulate. For example, 2. 1 times 2 equals to 2. And the next position is we already have 2. And now 2 times 3. We got this. It's 6. Right. And then we will get the next one is 6 times 4. We can get 24. So now we got the first prefix product. And then let me think about. So is that correct? I'm thinking. I'm trying to use the prefix idea. It's like we traverse from the beginning to the end and then get another prefix product to this one is from the left to the right, and another is right to left. So do the sum. It will be like 4 times 3, 12. That's incorrect, I believe. So how we can use the prefix idea? All right. So probably it's just like we have 1 here. If the pointer is here, we have 1. If pointer is here, like we already know the previous product is 1, so for example, like we can have a number here in one. For this one, I will make it as the private. So yeah, so we have a pre, and then when I traverse to here, we'll first update product array equals to product I minus 1 times pre number, so it will equals 1. And then for this one, when I move to here, and then I also update the pre number equals to numbers I for now, so now it's 2 already 2. When I move to here, so we start to update the pre-product I, and pre-product I is equal to the previous one times 2, so it will be like 2. And then when I move to here, so and also I update the pre-product one, it'll be 3, and or probably you can just say we don't have to pre-product, we can say it will be equal to numbers minus 1, right? And then for this 4, it will be 2 times 3 will be 6. Yes, this is the idea of like the prefix sum technique. So what it will be like is the prefix product times the numbers, and then we'll get the current prefix product. This will be the same. And then we got, probably this is not called prefix because it's traversed from the end to the beginning, or we can say from the right to left. We can call it like suffix product, right? So So about the suffix product, we are having the same idea. So this is the loop from left to right. And then we can loop to from right to left. We can also do the same thing here. For the first one, we always say it is 1. And then for the next one, it will be equals to 4. 4 times 3 is 12. And then 12 times 4 is 24. And now you can see that we got a prefix product and suffix product. If we like get multiplied from the prefix product with the suffix product, we already got the answer, right? 1 times 24 is 24, and 1 times 12 is 12. 2 times 4 equals to 8, and 6 times 1 equals to 6. So my idea is like traverse from like using the prefix sum technique. Prefix sum technique is like we create probably 2 arrays to get a sum from one is from left to right and another is right to left. But now for this problem, we are convert prefix sum to the prefix product. We can do the same thing. So we loop from the left to right. And usually we will initialize here's we say like initialize the first one equals to 1, and then start. So then we loop from left to right and start from the 1, position 1, not the 0. Same to here and start from the 1. Right, so this is my idea to solve this problem, and the time complexity will be like this is on, this is on, and also we have and also loop these 2 arrays and get the answer. Equals to pre-prom I equals to times I, right? And then we can just return the answer. So this is my idea. And now let's come to the coding part to prove this idea. And now we first will start to initialize an array is pre-product. Like the numbers. Pre-product array new int. We initialize the array, and the array, as we said before, the first one will be also always 1. To right. So now we start from 1 because we already initialize a number on the 0 position and the pre-product. I will be equals to I minus 1 times numbers I minus 1. Right. And then now we have another array, but what if like we don't have another array and to save some space, right? As we said, I can also because we already have the prefix product, and we can probably initialize a number. Probably we can, for example, combine these two steps to this. For example, like we have in suffix number or suffix product, right? First of all, it always be 1, and then the answer I mean from the left to right equals to the product product I times the suffix product, and then we can update the suffix product to the current numbers, and then we can continue to move the I pointer right. Continue to move the I pointer so the suffix product equals to the numbers I also times itself. For example, it is 1 here, so it times 4, so the next will be 4. So that's why we have 4 already. So when we are going back to answer I, we can already get the suffix product 4 times to the previous number, I mean pre-product number 2, right? So here we can have suffix product equals to 1 and 0. So we loop from the right to the left to update the suffix product, but before we update the suffix product, we have to get the answer first. So int answer is our array, and the answer is word equals to 1. Oh, we don't have to initialize the number here. We just start calculate the answer. It equals to pre-product I times suffix product. Like we have the initialized suffix product. After we get the answer, we can start to update the suffix product, which equals to itself times the current number in the numbers array. Right, so I believe this will be the answer. In any corner case, like for example, the numbers array only has 1 letter, if it only has one letter, we can just directly to get 1 times, yeah, this is also the 1 times 1. Probably that will be weird. Like the answer, we only have only one letter, so the I will be 0, and the pre-product will be 1. And the suffix product will be also 1, and suffix product always 1 times 1 equals to 1. Yeah, that's right. So not that's right, I mean, yeah, the length of the numbers will always greater than 2. And yeah, right to left. Yeah, cannot think about any corner case. Let's run it. Yeah, so it's already accepted. Cool. So now from this problem, you may probably learn about what is the prefix sum technique, and it can also be applied to, like for this problem, is prefix product or prefix other things. And what this technique is talking about is it will get all the previous numbers, sum before, or suffix sum or product, from left to right or right to left. This is the whole idea, and what we want to get is results, and it means we can already exclude the numbers on the current position. So hope you can learn something from this video. Thanks for watching.